Okay, remember why I assigned this problem to you? Remember, we're starting to look at velocity and displacement, and we can look at things either with formulas and try to mash it out with a formula. We can also look at things by graphing them, and graphing them is a really convenient way to look at things. So let me point out how we can tackle this particular problem through graphs. It's much easier. So, okay, a 100-meter race. So what do we know? So we have a 100-meter race. So the distance these people are traveling is 100 meters, and they both take 10.2 seconds to do that. And then I have two racers, so what I'll call them 1 and 2, Maggie and Judy. And they have a couple of differences. So, so the thing I want to do is I'm just going to graph the velocity for this. So let me see. So here's racer number 1. So we'll call it Maggie. Let's graph the velocity versus time. So what's going to happen? So they tell us it takes a total of 10.2 seconds to get to the endpoint, and they accelerate. And Maggie accelerates for 2.0 seconds, and she gets to some maximum velocity. So this is what it looks like. So she can get to some maximum velocity, and then she's going to continue on at that constant velocity for some time. So first question is well, what's this acceleration? Well, if we know the velocity, right, that'd be easy, easier to do. So we can do that. So let's figure out the velocity, and then from that we can get the acceleration that happens in the first 2 seconds because it gets up to that. So that's what we're going to do it graphically. So remember, acceleration is going to be the slope of this line, right? So the rate of change of velocity with respect to time, and displacement is going to be the area under this curve, right? So how far they travel is going to be the sum of all this area. So what I'm going to do is I'm going to figure out this area just graphically, right? I'm just going to be looking at the graph and trying to make sense out of it. So this area under the curve is going to be my displacement, and it's going to be 2 segments. So I have a triangle, so 1/2 base, which is 2 seconds, times height, which is my maximum velocity that she achieves. So I'll call it v. And to that, I'm going to add the area of this. Well, this is just this time segment, which is what, 8.2 seconds, times the height of this, which is the maximum velocity. And we know a value for this, right? This value is going to be how far they've traveled, and it's a 100-meter dash. So we know this is 100 meters. So what do I get? I get v plus 8.2v is equal to 100. And I can solve that with simple math. And I get a velocity, what I get, 10.87 meters per second. All right, so this is the velocity for the first, can't even see it, right? So it's the velocity for the first one. So what I did is I found the two areas, and I found the area under the curve for the triangle. I found the area under this square, right? So for the rectangle, and that adds up to 100 meters. I do a little bit of math, and I get to the velocity, right? So I can get acceleration from this, right? So acceleration is this rate of change, right? So acceleration is the change in velocity over change in time. My change in velocity, I go from 0 to 10, so it's 10.87. My change in time is 2 seconds, so this is going to be 5.4 something, or we'll call it 4 meters per second squared. I'm going to do the same thing for the other person, and I'll get a slightly different issue. Right? So let's do the same thing. So I'm going to have a velocity time graph. She's going to accelerate for a period of time. It takes her longer to get going, right? So this point is 3.0 seconds, but they finish at the same time, so it's 10.2 seconds. I want to be able to find the slope of this to get me acceleration, and this area under this curve is going to equal my displacement, which is 100 meters. So let me do the same idea. So now I'm going to have my area under the curve is going to be the sum of the triangle plus the rectangle. So my area under the curve is going to be 1/2 my 3 seconds, my base times my height of velocity, whatever it is for this case. So it's going to be different velocity, right? So this is velocity of the second person. Plus now I have 7.2 seconds at that velocity, and that's going to add up to 100 meters. Okay. So what's this going to be? 1.5 plus 7.5, so 8.7 times that person's maximum velocity is going to equal 100 meters. And my maximum velocity is going to be that over, did I do this math? It was 11.5, yeah. 1.5 meters per second. So what's the acceleration of that person going to be? Well, acceleration is going to be change in velocity over time, which is a change to 11.5, and it took them 3 seconds to do that. What did I get? 3.83 meters per second squared. Okay, again, there are a couple of ways to solve things, and sometimes it's really helpful to draw a graph to help you figure it out, and sometimes it's easier to try to mash it with equations. You can mash this one with equations, but it's a heavier go. So anyway, I hope that's helpful, and I'll talk to you soon. Bye.